we want to talk about the different concepts about the statistics. The first concept is the different types of the statistics. We have described statistics. It deals with taking the data from a set, organizing time in tables or graphs, and calculating numbers that summarize the set studied. And we have the other type, that is inferential statistics. This is deals with drawing conclusion for the population based on the results of a sample and degree of reliability of this conclusion. Well, we have different concepts. The first concept is the data. Data are plain facts, usually raw numbers. Think of a spreadsheet full of numbers with meaningful description. We have the concept about the information, that is stimuli that has meaning in some context for each receiver. When information is entered into a store and a computer, it is it, it's generally referred to as a data. Random sample is a sampling process where every item in the population has an equal chance of being chosen and placed in the sample. Population is the universe of event numbers under study. The universe contains all the entities one wishes to consider in a given situation. And we have two types about the sample. That is, sample is a portion of the population used for statistical analysis, and sample size is the number of individuals that make up the sample. We have the probability sampling. Is the selection process that considers the likelihood of selecting a particular number or attribute for the population. Variable is a numerical attribute that can take of different values. Variables constitute the characteristics of a sample set to which statistical analysis will be analyzed. The parameter is a numerical measure describing a particular characteristic of a population. Since we typically do not study population, parameters are often universal and must be estimated. And we have just one different about the qualitative variables and quantitative variables. Qualitative variables, those that cannot be measured, and quantitative variables, those can be measured. It's just that. Publish sources of data is are collected from either a primary or secondary source. And we have some examples about that. Described and continuous random variables. A described variable is a variable whose values is obtained by continuing. For example, the numbers of students present or numbers of red marbles in a chart. A continuous variable is a variable whose values is obtained by measuring. For example, time it takes to get to school or distance traveled between classes. And random variable is a variable whose values is a numerical outcome of a random phenomenon. We have three examples. A random variable is denoted with a capital letter. The probability distribution of a random variable x tells what possible values of x are and how probabilities are assigned to those values. Uh, we have one example about the let x represent the sum of two dice. Then probability distribution of x is as follows. The graph, the probability distribution of a discrete random variable construct a probability. A continuous variable x takes how values in a given interval of numbers. The probability distribution of a continuous variable is as shown by a density curve. The probability that x is between an interval of numbers is the area under the density curve between the interval endpoints, and the probability that a continuous random variable x is exactly equal to number is 0. In this case, we have a concept map about the statistics. We have some concepts. Uh, well, we have the finite statistical population, infinite statistical population, and sampling. Uh, Finite statistical population is one which the number of values that compose it has an end. One example is the statistical population that indicates the number of trees in a city is finite. It's true that it can vary with time, but at a given moment, it's finite. It has no end. Uh, the definition about the infinite statistical population is this the population that has no end. For example, we have the number of planets that exist in the universe. It's obviously that the number of planets is infinite, so although it may be finite, the number is so large and unknown that is statistically assumed to be infinite. We have sampling. We have two types of the sampling, that is probabilistic sampling and non-probability sampling. Probabilistic sampling is the technique of choosing the sample, and we have one example. Simple random sampling. The relevant variables in the sample have the same probability function and are independent of each other. And the definition non-probability sampling, it's a sampling technique where samples are collected in a process that does not provide individuals. One example about this is novel sampling. This is usually done when there is a very small population. In this type of sampling, the research asks the first subject to identify another potential subject who also meets the research criteria. So now my friend has some questions, so you can tell me the question, please.
¿La estadística puede ser clave para tu empresa?
Of course, it's key. This can be made up of statistical experts who will be in a charge of applying what is considered necessary.
¿Qué parte de la estadística se adapta a la carrera?
The vast is majority science, as we saw. Many concepts can be applicable to university career.
¿Es necesaria la ampliación de la estadística en la vida diaria?
Really, I don't know if to daily life. Science is much more complicated than that. Although without the book, we have used the statistics and we have not released it.
¿Crees que la estadística sea clave para el éxito de tu empresa?
Of course, the good management of statistics can make your company have a warranted success.
¿Cuál es la parte de la estadística que encuentras más interesante?
I think that the fact that you can predict whether it's relevant to launch a product to market, or if the service you plan to provide will be in a demand. That is very interesting. So I think it's all for today. Thank you.